Hi everybody. I'm going to talk to you about defining a class, not just as in defining a class in your code, but more specifically defining a class in terms of terminology, why we use it, and what it is. So what exactly is a class? Well, a class is a type. So like I mentioned in the previous video, it's very similar to int, bool, or string in C++. It's a type, it's a data type. We're defining a new data type, and we're calling that a class. All right. So if this is true, so if A is a class and obj or object is the name of an object, then obj is of type A, and obj is an instance of class A, and obj is an object of class A are all true, and they all mean the same thing. All right. A class is also a recipe for how to create an object. So like I was saying, it's creating a new data object of our own. So we get to create a data object. We get to define all of the things that are important about it. So I talked about identifying what things are important out of a real life object to put into your code in the previous video. This is us essentially creating the recipe for what an object is. We want to be able to create these kind of objects from a kind of abstract conceptual thing, and that's going to be our class. So we're going to say that the number of wheels is important, we're going to say color is important, we're going to say max speed is important, we're also going to say what methods are important, so being able to move, to stop, and defining all of these in our code is really what makes a class interesting. This is what makes a class useful. We use classes because we don't have data types representing the objects that we need. So we write our own data types using this class approach. Now, you may have done some of this in the past. So when you were in your algorithms course or your data structures course, you may have found yourself writing little pieces of things that contained data, that encapsulated data. There's that word again, encapsulation, where you encapsulate all the things you need about a particular thing in your code in a particular piece of reusable code. So if you take a look, for example, at a linked list or even a graph structure, you would probably have something called a node. Now this node is going to have a data value and it's going to have data pointers to, if it's in a linked list, if it's in a singly linked list, to the next node in the list. If it's in a graph, it might have a left and a right. This is essentially a class. This is what a class looks like. That node is a class, and each specific instance of that node is an object of that class. Now, you didn't use that terminology when you were writing that code, but that's essentially what we're doing here. We're creating reusable classes so we can create instantiations of that class as particular objects. This also allows us to define behaviors that we want these objects to share. So for example, every node in that linked list, we probably want it to be able to move to the next item in the list. So there's probably a method that allows us to do that. Again, this is essentially object-oriented programming, so you've done this before possibly without even realizing it. But we're going to talk about how to write a specific class, particularly in Java, since that is the language we'll be using for this course, in the next video. And I'm going to do a live coding example for how to write that class so you can see what the language structure looks like, what keywords are important, but also in general the process of how we actually go about translating our thoughts and notes about what we want a class to look like and what it actually looks like in the code. So that's going to be in the next video. Make sure you watch it.